Okay, good day, Gretkov. So today we are doing inverse function. Inverse function. So we're going to do the inverse function for the linear, the one-to-one function, and the quadratic, and lastly exponential functions. Okay, so today we're doing the inverse only, and that's what actually what you cover in what you call in grade 12. Okay, grade 11 you find that you do the the linear function, quadratic, exponential, and the exponential function, okay, in a hyperbolic function as well. Okay, so today we are covering inverse functions. So we're going to look into a line of symmetry as well, point of intersection, and how do you actually sketch both inverse and the normal function in the same on the same axis. Okay, so let's get started here. Okay, so just a reminder here of what a function is. So a function is a relationship between x and y, okay, where for every input of x value, there is only one output of y value. So always remember that what a function is. So we have to put a you must always have single output there. You must always have one output. Okay, so let's have an example there. The first function that we're going to deal with, the linear function, which is in the form of y is equal to ax plus q. Okay, so we know that the domain, what is our domain? Remember, domain is x values. We find the x value or input values. Okay, then here the range, this is the what output values, and it actually describe your y values. Okay, so whenever we're talking of the domain, it's the x values, and range is the y values. Okay, always like that. Now, so wanna see here, when you're saying, when you input 2 there, that's our domain in this case, and we substitute, say f of 2, which is in this case 3 times 2 minus 1, we get 5 here. So that's our part of our range, isn't it? Now, what we see there is that when you're talking of inverse now, we want to have an expression, but this one is an expression, it's a function, okay? So inverse of this function must if we input 5 into that expression, we must get 2. So in the inverse, what we're just doing is we are just interchanging the domain and domain and domain and range. That's what we're doing. So whatever we are going to have a domain here, okay, now we have our range this side. Okay, so that's what I'm just doing here. That's what you need to understand when you're talking of an inverse function. Okay. Okay, so here we are saying we want to find the inverse. So if we put the input that if we substitute with 5, okay, we get what is it? We get what you call 2. So what are we going to do now? The rule, calculating the inverse. Step number 1, you need to interchange x and y. So in the equation, that is what is it? X is y is equals to what? We know that y is equals to 3x minus 1. Now, what do you need to do? You need to interchange. Okay, interchange. What is it? What you call interchange x and y. So it's going to be x is equal to 3y minus 1. Now, what is the second step? Second step now is make y subject of the formula. So when you want to say, when you're saying subject to the formula, we want to say in the form of say y equal to. Okay, so from this equation that we're having, we're going to say 3y is equal to x plus 1, because 1 comes this side. Okay, then y, we divide by 3 both sides, so it's going to be x plus 1 over 3. So this is our inverse here. Okay, this is what we call the inverse, and we represent our inverse by -1, f of -1x. That's x plus 1 over 3. That's what we have there. That's our what we call our inverse. So let's put here and see if we can get 2. It's going to be x plus 1 over 3. Okay, x plus 1 over 3, and we want to see if we can get 5 there. You can get 2 there. We're going to say, all right, 5 plus 1, put your bracket there, 5 plus 1, then divided by 3. What do we get? We get a 2. Okay, so that's what we're talking about here. That's what we're talking about. We get it true. So in this case here, this domain, we're talking of what we call the domain. This becomes our domain in this case, and this becomes our range. So that's the interchange. So that's why we are interchanging here. Okay, we are interchanging the value of what is it? The x and y. Okay, we're interchanging them. Okay, then from there you make y subject. Then you're done. That's how you find inverse for all, whether it's what called hyperbola, sorry, exponential, or what is it, or quadratic. You still use the same formula. Okay. Okay. So our question on linear function, okay, is we have an equation here. F of x is equals to 3x minus 6. Okay. Now the question is saying determine. The first question, determine what called inverse of f of x. The second question is saying sketch both f of x and the inverse on the same set of x's. And the third question is saying draw line of symmetry on the set of on the same set of x's. Now the fourth one, determine the coordinates of point of intersection. Okay, so let's start to do the what called the inverse here. Inverse, we know that, right? Y is equal to 3x minus 6. Okay, then what do? We interchange. X is equals to 3y minus 6. What do? We make y substitute the formula. It's gonna be what? 3y is equals to x plus 6. What's next now? 3y is equals to x plus 6 divided by 3, because we are dividing by 3 there. So that's our inverse. So we've done the first equation. Okay. Now, the second question is saying sketch both of them on the same set of x's. Okay, now, what do you know about sketching? Remember, sketching, we need to find the intercepts. Okay, you need to find the intercepts. Okay, so what we're going to do now, we know that, all right, f of x equal to 3x minus 6. Okay, then we have got f of negative 1x is equals to x plus 6 over 3. Okay, now what's next? Now we need to find, what is it? The intercepts. So we're going to say x intercept. So whenever you're drawing, or whenever you're sketching linear function, all you need to worry about are intercepts, x and y, where it crosses the x and y. So when y is equals to 0, okay, when y is equal to 0, 3x minus 6 is equals to 0, then 3x is equals to 6, then x is equals to, we divide by 3 both sides here, x is going to give us what? X is going to give us 6 divided by 3, which is going to be 2. Okay, so our x is 2. Okay, so the coordinates there is going to be 2 and 0. Okay, that's the first coordinate. Okay, now what about y-intercept? Y-intercept. Okay, y-intercept is what? When x is equals to 0. Okay, so when x equals to 0, y is equals to 3 minus 0 minus 6, where it's equal to negative 6. So our coordinate there is going to be negative 0, negative 6, like that. That's our y-intercept. Okay, so we have y and x and y-intercept. Now on this one here, we need to do the same. Okay, x-intercept is going to be when y is equal to 0. So we know that, all right, when y equal to 0, what we have here, we're going to say 0 is going to be equals to x plus 6 over 3. We multiply by 3 throughout to cancel here, to cancel the 3 there. So you're going to left with x plus 6 equal to 0. X is going to give us what? Negative 6. So the coordinate there is going to be negative 6 and the 0. Now, what about what we call y-intercept? Y-intercept. Y-intercept is going to be, when x is equals to 0, what we have here, when x equals to 0, we're going to say y is equals to x 0, sorry, plus 6 over 3, which is equals to 6 divided by 3, which is equals to 2. Okay, so we have got y equal to 2 there. Y is equal to 2 there. So this is 0 and 2. Okay, now that's what we have there. Okay, that's what we have there, and now we want to sketch here. So let's try to sketch here our graph. Okay, so we've got 2 for x and -6 for y. Okay, then we have got -6 for x and 2 for y. Okay, so let's see what we have here. Let's put our maybe our graph there. Okay. Always remember x, put the x and y. Now we know that the x, when x goes to 2, okay. Now what is another coordinate? 2 in terms of what we call -6. Here is going to be -6. Okay, then here we're told that on this side here, this side is -6 for what, for x. Okay, then it's 2 here. It's 2 for y. Okay. Okay, now that's what we have there. So what are we going to do now? Remember what I said, you must connect these two lines here. Connect them. You have to just link the straight line. Draw a straight line there. Okay, then another one. Draw another straight line again there. Okay. All right, that's what we have there. So this, you must label, you must be able to label your graphs here. So this one is what? F of x. F of, is it f of x? For, yeah, f of x with the 2 and -6. F of x equal to 3x minus 6. Okay, and this one is f of, remember the inverse, equal to x plus 6 over 3. That's what we have there. So those are the two equations that we have there. That's, so we have answered what we call number 2 there. Now the line of symmetry is actually passes through the center there. It divides you, what is it, the two lines there. So this is actually the line of symmetry. It passes through 0. It passes through the center there. It's line of symmetry. Now, so you've done what called what is it? question 3. Okay. Now question 4 is saying determine coordinates of point of intersection. Now, point of intersection. Now, on point of intersection, here's what you need to remember here. When you have got two equations, when you're given two equations, in this case here, you have got f of x is equals to x plus 6, okay, over 3. Or let me just say y is equal to, okay. And the other one, again, we can also call it y equal to, okay, it doesn't matter. We can call it y is equal to what? Y is equals to, what is it? Y equal to, let me just say, f of -x is, this is a -1, sorry. Then this one, f of x, is going to be 3x minus 6. So what you need to do there, you solve simultaneously. Or what do? You just equate the two. Okay, you just equate the two, or you're just solving simultaneously. That's what you're doing here. Solve. Okay, so simultaneously. So what are you going to do there? You know that y and y is equals, these are two are equal. So it means that these two are equal. So it's going to be x plus, so this first equation, second equation, x plus 6 over 3 is equals to 3x minus 6. Okay. Now, what do you get there? You will say x, you multiply, take 3 that side, it's going to be x plus 6 is equal to 9x minus, okay, so 3 times 6 negative 6, negative 18. Okay. Now we take we take our 9 that side is gonna be x minus 9 minus 9x is equal to minus 18x minus 6. Okay, so we just want to find out minus 18. Okay, 18 plus 6, what do you get there? We get 24. Okay, we have 24 there. Then what you call minus, sorry. So we're going to say, all right, 1 minus what? 1 minus 9, get minus 8, minus 8, x, like that. Then we divide both sides by negative 8. By negative 8, what do we get? We get our x as what you call 3. So point of intersection in terms of x is actually 3. This is actually 3. Okay. So now how do we get, what is it? How do you get the what is it? The corresponding value? We substitute in end of the equation. We know that it's gonna be in equation 1, in equation 2. Sorry, it's gonna be y is equal to 3 minus 6, which is gonna give us what? 3 times 3 is 9. Okay. 3 times 3 is 9. 9 minus 6 is actually 3. Okay. So it's gonna be 3. Okay, so now the coordinate, remember, the coordinate must be in the form of what? X and Y. Okay, so we have 3 and 3. So point of intersection here, this is our point of intersection, is 3 and 3. Okay, so it means that it's 3 units actually, the what called in terms of the x-axis, and 3 units in terms of what called y-axis. Okay, so that's so your answer, your questions will actually be fully answered. Okay, that's what you must do here. Okay, so now let's move on to inverse what we call of a quadratic function. Now we have our equation, the f of x equals to x squared. That's the general form. Okay, now in this case here, we're going to say that if our domain, if our x value is what? If our input value is 2, okay, what is going to be our y in this case? So we're going to say it's going to be 2 squared. Okay, then now if we put, say 2 squared, we get a 4. Okay, the answer is 4 there. So now we have a 4. Now I want to have to get 2 there coming from this side now. Okay, so we're going to say now this one is our 4. Okay, so we want to find this inverse of us. Inverse, and what is the direction? Direction now is this side now. It's this direction now. That's what we want. We want to find what is actually the function here, inverse function here. Okay. Now what do? We have our equation there, remember? Now we're going to interchange here. So if we interchange, what do we get? We get x is equals to y squared. Okay, so in other words, y squared is equals to x. Now how do you remove x there? I want to move to the power 2. We say y is equals to plus minus root of what? Root of x. That's what we have here. Plus minus root x. That's what we have. So this is the inverse here. So that's the inverse for what is it? For the quadratic, which is parabola. Now here we're going to say now our expression there is plus minus, okay, root of x. So in this case here, we're going to put, remember now, we are going to put 4 here. If we put 4 there, so root of 4 is what? Root of 4 is what? Is 2, okay? Then we know that it's going to be plus, it's going to be minus, and plus 2. So we've got 2 and what we call, and 2. Remember what I've indicated in the first lesson, function 1, said this one is many to one function. Quadratic function. It's a many to one. What do you mean by that? You put 2 values, okay? If you put 2 values, minus and positive, you get the same value here. So it's a function going this way. But now, if you are taking it going back then, okay, from 4 to what call with its inverse, it's gonna give you plus or minus. And now, should we say our inverse is a function? No, it's not a function in this case because we're getting 2 values of y. Okay, we're getting two values of y, and how you draw it. So here's a sketch here. Here the sketch here. Here's what we have. Okay, so this is a graph of y is equal to x squared, and when we have root of x, it's graph of root of x is like that. Okay, graph of this one is graph of y is equals to plus minus root x. But now in this case, now this one is not a function, not a function at all. So this one not a function. Why are we saying that? Because for every x value, we get two values. Okay, so for every x value, we get one, and we get another one, another y value. So we don't want that. We must get one y value. So this one is not a function. So for the first one here, the domain for the first one, y is equals to x squared. Okay, the domain there is x element of real numbers. So what do we mean by that? We're saying from negative infinity to positive infinity. That's what we're saying. So in this case here, in the sense that our domain is like this, x element of real numbers, we can't have, the inverse won't be a function. So what do we need to do? We need to restrict the domain, to make inverse a function. So we need to restrict the domain. So we need to restrict it so that we can have what is called a function in our inverse. Okay. So let's have something here we're talking about here. Let's restrict here. In this case here, this is the graph of what? This is the graph of x squared. So what we're going to do here, we're going to say, all right, for x less than 0. Okay, that's our domain there. Okay, so our domain, we are saying for x less than 0. What do you mean by that? Our equation will cover this. Okay, that's what will be our what you call our equation. So for when x is equals to less than 0, that's our what you call our equation there. Then now, what will be our inverse? Our inverse. So here, let's just put it some dots here. Okay. Okay, so when x equals less than 0 for y equal to x squared, our domain there, we find that our range also will become restricted. So it's gonna be y less than what? Y less than what you call less than 0. Okay, and what is it? This equation here is f of negative x equal to negative root of x. So this part is a negative root of x. So remember here, when you have got something like this one is negative root and this one is positive root. Okay, so here it's going to be negative root of x. That's what we have there. So that's how you restrict. So now this one now is a function. Why is it a function here? Because if we substitute any value of x here, we get a corresponding one value. So here, if you put an x value there, we get a corresponding one value of what called of y. So we get only one corresponding value of y in this case. Okay, so that's what you must always remember there. What is it? So here's now. The other thing is we can restrict the domain by with what you call y is equals to x squared. Okay, for the domain where we are saying our domain is x greater than 0. Okay, x is greater than 0, greater than or equal to 0 is fine, greater than or equal to 0. Now here for this case here, we have our quadratic equation is no longer like what we used to have with the dot, so that it just indicated something there. Then what we want really is this one. Okay, for x greater than or equal to 0. Oh, I forgot now to put x and y. Okay, in the origin there. So remember that the first thing that you must always do. Okay, so you mustn't forget now. So here is what we have here. So this one is a graph of what called y equal to x squared. Okay, and for which domain? x greater than or equal to 0. And what is the inverse there? The inverse now is what you call y equal to positive plus root x. And in this case here, what's called our domain for this case as well, domain for this domain is what? Domain is x greater than or equal to 0. Okay, x greater than or equal to 0. Okay, now what about the range? Range is y greater than or equal to 0 because that's where it occupies the values above 0. So in this case here, the domain for this is actually domain is x greater than or equal to 0. So here, that's what you need to remember here. A domain is still actually on the positive x. So domain doesn't change in this case, irrespective of which one you it's because of your restrictions, it doesn't change because it's going the same way. So this is what you must remember here when you're dealing with the quadratic equations. This is what you must remember, because they might give you an equation like that. They might give you something like that, just a sketch like that. Okay, then they tell you what will determine whether this one is a function or not. Okay, and support your answer. So if it's not a function, okay, what must you do now to make it a function? Okay, you must restrict it. Okay, so it's not a function because for every input of of x value, you get 2 output of y value. Okay, so let me just explain it in writing here. So when we are saying, when we have put something like that, okay, so we are saying this is graph of y is equals to plus or minus root of x is not a function, okay, because for every x input value, to output y values. Okay, so we need one only. We need one output. So in this case, there are 2 output values. So it needs to be restricted. Okay, so domain of original graph y equal to x squared must be restricted. So to make its inverse a function, the domain must be restricted. Okay, so let's try to see if we can have a question here. Now, so here we have a question there. What question do we have here? It's f of x is equals to negative 2x squared, okay? And the first question is saying determine what you call the inverse. The second is sketch the graph of what you call of each of the function f of x and its inverse. Restrict the domain, okay? Then what is it? What you call, and also sketch, okay? Sketch each new function in this domain, okay? And write down the domain and range for each, okay? So this is very simple here. What are we going to do now? We're going to say, what is it? Y is equal to negative 2x squared, okay? Then what do we need to do here? We need to interchange, okay? X is equals to negative 2y squared, okay? Then we make y substitute the formula. So y squared is equal to x over negative x over 2, because remember we divide by negative 2 here, both sides. So we're going to have that. So this one is going to be equal to y is equals to, okay, root of, okay, plus minus, okay, root of negative x over 2, okay. Now, some of you are worried, oh, why is it a negative? You said you can't have a what called a negative, what is it? A negative what is it? You can't have a negative, what do we call, a negative root. Okay, we can't have a negative root. All right, in this case here, remember the x value there, the x value, we don't know the x value. So that's why it's negative. So x, if x is negative, probably it's going to be negative. If x is going to be negative, it means that it's going to be negative times negative, it gives you a positive value. Okay, so don't worry about the negative that you see inside there. Okay, so it's actually correct there because we have an x, and then x is not a number, it can be any number. Okay, so if it is negative there, our root is going to be fine. Okay, so don't stress about that. Now, so let's move on here and see what we need to do here. So this, our inverse now becomes what? Plus minus root of negative x over 2. Okay, that's our value. That's our first equation there. Now sketch the graph of f of x and f of negative. Okay, now let's do it now and see what we have there. Remember, graph of x squared, you don't need to stress about anything. It's not going to pass anything. It's not shifted. It's not done anything. Okay. The two, remember what I said about the two just do the narrowing and actually the expansion of the graph. It doesn't shift any graph there. Now, so let's quickly do what you call, because some of you wonder, why are you not calculating the intercepts? But in this case, there's no need for intercepts. Okay. No need for intercepts because we know that it just touches at 0. Okay. So we've got the y, we've got the x. Now, so our graph, because of the negative, remember, so remember we said when we are sketching, you must check with the x, what called the value of a here, because remember with our general equation here, when you said f of x is equals to a x squared plus what called plus q, we said if a is negative, if a is below or 0, our graph generally will look down. If A is above 0, generally our graph will face down. So we say this one is the graph is sad, and this one is the graph is what called is happy, smiling, isn't it? So that's what you must remember there. So when A is above 0, when it's positive, there it's facing up. When it's negative, it's facing down. So in this case, it's going to be easy for us because we just know that it just touches the center. Okay. So it just goes on like that. Okay, sorry. Now, so this is what we have there. Okay, that's what we have. In the inverse here, the inverse, because remember what we said, is minus, so it's gonna be the inverse is like that. So that becomes your inverse. So in this case here, your inverse is what you call of f of x, negative 1, x is gonna be equal to plus minus root of negative x over 2. That's what we have here. So in this case here, we have answered what you call the second question there. Now, the third question is saying restrict the domain of f of x. So in this case here, the domain, okay, so in this case here, we have put y equal to x negative 2 x squared, and the domain here in this case here is x, okay, x what you call element of real numbers. Domain for this is element of real numbers. It just from negative infinity to positive infinity, okay, because this graph here will go in up until infinity now in terms of x, so it's fine. Now what about our range? Our range in this case here, we know that it's y less than what you call less than or equal to 0. That's what we have there, because the y is going to occupy values from 0 downwards. Okay, now what about for inverse? For inverse, in this case here, the domain, its domain for inverse is actually x less than or equal to 0, because you can see that it's occupying values that are below 0 here, as you can see. Now, what about the range? The range in this case here is actually, what is it? The range in this case is what called is y element of real numbers, because it's from negative infinity to positive infinity, okay? It's actually taking any value there. So it's y element of real numbers. And we don't want that. We don't want that, okay, in a function. Now, let's see what we're going to do here. Let's quickly do restrictions here, okay? See what we can come up with. So here, this was what the first one, okay, the third one, the second one, sorry. And let's move on to the third one. Let's do the third one here. Now, the third one there, we want to restrict. So we're going to say for f of x, y equal to negative 2x squared. So for the first restriction, okay, domain, we're going to make the domain, our domain, we're going to say for x less than or equal to 0, okay? Then for the second one, we're going to say y equal to negative 2x squared, but we're going to say now the domain, our domain is x greater than or equal to 0, okay? Now that's what we'll be having there. So we're restricting the domain here because it's no longer element of real number in this case. We are restricting it, okay? Now we want to see what would be our range there. We'll find out the range. The range what call doesn't change. The range doesn't change here. The range does not change. The range is still less than 0. Y less than or equal to 0. But what we are worried about is this. Okay. So now let's come up with what call with our graph now. Our graphs. We're gonna draw just more graphs here, but I think you'll be able to actually navigate and see what's actually going on. All right, draw another one here. Okay, remember x, y, x0, y, x0. Always remember that. Remember to put your what is it, your values there. Okay, so for x less than or equal to 0, we know that we have our graph here like that. Okay, now so it's inverse. Okay, so what do we have here? We're going to say here is what is y equal to what is it, negative 2x squared. Okay, and this one here is f of x negative 1x equal to, in this case it's, what is it, remember it's plus minus, it's going to be negative, okay, root of what is our inverse there, root of negative x over 2. Okay, that's what we have there. Now what about this one here? This one, when x goes what called what did I say, what did I do here? When x equals greater than, okay, greater than or equal to 0, okay, that's fine. Here, what we have here, we're looking at this side here, okay, so it goes on like that because x is greater than or equal to 0. Now, what about its inverse? Its inverse is like that, okay. So that's what we have here. That's what we come up with. Here is an equation of what is it? Y equal to negative 2x squared, okay, for the domain x greater than or equal to 0. Here for the domain x what you call less than or equal to 0, okay. Then for this case here, it's what is what is it? It's what is it here? For this case, what we have here is y f of negative 1 x equal to plus, okay, root of negative x over 2, okay, because remember we've got plus and minus are root, okay. Now that's what we have there. Then what else do we need to see there? Yeah, then our range, our domain there, our domain is still the same, x less than or equal to 0. Our range is what you call y greater than or equal to 0, because in this case it's going to take values of y above them. Then in this case here, d domain is still the same, it's x less than or equal to 0. Our range in this case here is taking y less than or equal to what is 0, because y is actually below there. That's our range, okay. So the range here is the same, okay, the range here is the same, y less than or equal to 0. So this is what you just need to remember there, y less than or equal to 0, just like that. So this is what you need to remember when you're dealing with what is it? What called quadratic or a parabola. Okay, so you must restrict to make it a function. Now it's one-to-one, one-to-one function, and this one is also one-to-one a function. Okay, now what is there any last equation there? No, we have done everything because we wrote the domain and range of each sketch. So these are the two sketches that we have done, and we've done almost like everything. Okay, so let me just write some questions that you can practice with. Okay, so these are the questions that you can actually do. Okay, these 4 questions. Just determine the inverse. Okay, and also try to sketch. Okay, sketch and sketch. Okay, just try to sketch and determine the what called domain and range as well, just to practice there. Okay, and you can also find some exercise on on your textbooks. Okay. Okay, so now let's look into the last part, exponential functions. Okay, the inverse now, exponential function, you must know that it's in the form of what, a to the power of x. Okay, so in this case here, let's have our domain and our expression y is equal to 3 to the power of x, and our range is output that we're expecting. So what we're going to do here, we're going to say 3 into the power of what, 3, we substitute for 3 for x, then what do we get there? We get our range. What is the value there? 3 to the power of 3 is should be 27. Let me see there. 3 cubed. Good. All right. Now here what we have here, 27. Okay. So now we have our 27 and we have our function there. Okay. Now I want to make sure that, all right, what is the expression? What is the inverse there? Okay. What is the inverse that we can put there? Inverse function that we can put to get our 3 from 27. Okay. Now we're going this way now. We're going the other way now. Okay, so I want to see how do we get that what we call that equation. Okay, so I just want to explain to you some basics that you need to understand here, the relationship between your exponents and logarithms. Okay, so now you need to learn about logarithms, logarithm and exponents. So I'm just going to give you a brief explanation here. Okay, so we know that, right, we have our exponents like in the form of a to the power of b is equal to c. Okay, so in this case here, our exponents relationship between these two is going to be log, okay, a base a, okay, c must give us b. Okay, now what am I saying here? I'm saying if maybe let's say 2 to the power of, or let's say 3 to the power of 3 to the power of 3 is 27. Okay, we say log base 3 27 must give us the same answer. So let's see if we can get it now. So we have our log. Where is our log here? See this thing here. Sometimes it hides. Where does it hide here? Where is the log here? Okay, yeah, now the log 3. Okay, now 27. Now what do we get? We get a 3. Okay, that's what we're talking about here now. That's what we're talking about. So we get a 3 there. So now here's another thing about the logarithms now. Logarithms. So just a law that you need to know. If we say log a to the power of b is equals to b log a. Okay, so what do you mean by that? Log 3 to the power of 3 is not base. 3 to the power of 3 is 3 log 3. Okay, let me just say 2 here so that we can actually distinguish. Okay, so it's actually 2. So log 2 to the power of 3 is 2. Then we take 3 that side. Okay, the power. Okay, so let's get to see our question here, our problem here. What is our problem here? Our problem is saying we have 3 to y is equal to 3 to the power of x. Okay, so it's y equal to 3 to the power of x. Okay, the first stage, what we do, we interchange x is equals to 3 to the power of y. Okay, so basically now we're having 3 to the power of y equal to x. And what is our logarithm, the relationship saying? We say it's gonna be log, what is log? Log base what? Base 3, same base, remember? Same base, remember? and x is going to give us what? Y. Okay, that's what we have there. So our y is basically equal to log 3x. Okay, that's what we have here. So if we are dealing with the general equation here for y equal to a to the power of x, what you call the inverse there, the inverse in this case here, f of negative 1x should be equal to log base a x. That's what you must know, okay? That's what you must know there, okay? Now, the other thing that you need to remember there, remember when we did exponents, when we did the exponents, we said generally the graph is like what? The graph is like this. It passed through what? Through 1, okay? The graph is like that. Graph of y is equals to a to the power of x, okay? Now, and we say that if our a, okay, is a fraction, if a is a fraction, okay, where a, so in this case here, a is greater than 1 in this case, it's greater than 1, okay, a is greater than 1 in this case, but where a is a fraction, okay, it becomes, we have an equation like that, where a is a fraction, so we say is this one is y is equals to a to the power of x, but in this case here a is a fraction, so a we say is 0 less than a less than 1, okay? So a in this case here for this one, a is a fraction, okay? That's what you must know there. A is a fraction. What do we mean by that? This one can be y equal to half the power of x, and this one is y equal to 2 to the power of what? To the power of x. That's what we have. That's what it's just simply saying here. Okay. So that's what you must remember there when you're dealing with when you're dealing with exponents. So now, why am I bringing this? Now, the inverse now, when a, for in this case here, when a is above 0, okay, for a, okay, above 1, sorry. When a is above 1, what do we expect there? We have our f of x like that. That's what? That's our f of x equal to a to the power of x. Okay. What about the inverse? Okay. So the inverse here passed through 1 as well, but now graph of log is like that. That's the graph of log. It passed through 1 here. Now, so this is y equal to log ax. Now, that's what we have there. So this is a graph of log. But now I want to see what is it now if a is, we're saying it's between what was 0 and 1, it's a fraction, okay, e.g. 1/2. What do we mean by that? what do we have, sorry? What will be the difference there? Now let's save something there and see what I'm talking about here. Here we've got what? We've got y, we've got 0. Now, so in this case here, if a is a fraction, we know that the exponent graph will be like that, the reflection. So it's still passing at 1, okay? But now for what is it? For the inverse now, for inverse, it is still passing at what called at 1, okay? But now it's actually like that. That's what we have for the inverse now. So this one is for the inverse. So in this case here, this one is y is equals to log ax, okay? Or you can say log half of x, like that. That's what we're saying. So this is the fraction, and we can say this one is equals to ax. In this case, y is equals to half of the power of x. In this case, y is equals to 2 to the power of x. Okay, that's what you're simply saying there. Okay. That's what I'm simply saying there when you're dealing with the inverse. So always remember that when it becomes a fraction, you must know that the graph generally is actually like that. So here you're not going to be asked complicated questions here. So what you just need to master is what I'm telling you here. Okay. So let's see if we can have a question. Now it's telling us that what you call the inverse, calculate the inverse, determine the inverse of those two, okay, and just do a sketch as well. So we've got two equations, determine inverse for each of the equation and sketch both are what called on the same set of graph, okay. So let's see if we can do that. Okay, so we have our what call our inverse. Our inverse is y equals log 5x, log base 5x. Now, and what is it that we need to do here is draw the what call it has to pass at 1. Here you don't need to stress about anything here because the coordinates already you know that coordinates are 1. It just cross at 1 unless it is shifted. But in this case, when I'm doing the inverse thing, I don't think you will be given what call complicated stuff. Okay. Now, what we have here, we know that our corresponding what called inverse pass through also 1. Okay. So here's 0 and 1. Now, what do we have there? This graph looks like that. Okay. So this is what we have here. This is what we have. As simple as that. I forgot the line of symmetry. The line of symmetry is actually dividing these two lines, these two equations here. So line of symmetry is y equal to x. Okay. That's what we have here, separating the two. And this one is a graph of y f of negative 1x equals to log 5x. And in this case, it's actually the graph here. Okay, that's what we have there. So this is what you need to remember there. And when I talk of the domain and range here, let's also talk of the domain and range. So for the y equal to 5 to the power of x, okay. So if I took the domain in this case, domain, as you can see there, is that it takes any value of x, because from going there, it's going to negative infinity. It just approaches 0, but you never touch 0, okay? So it's going to up until negative infinity for x, and for the positive also, it also goes until positive infinity. So in this case, x is element of real numbers, or you can just say negative infinity to positive infinity. You are done, okay? That's what you must also do if you want. But giving this one is actually valid like that. Now, what about the range? Okay. What about the range now? Now, in terms of the range here, if you look at the range, if you look at the range in terms of what? In terms of y, okay? In terms of y will never be 0. So it's actually greater than, okay? It's greater than, y is greater than 0. For the 5 to the power of x, because it will never cross the x-axis where y is equal to 0. So it's always greater than 0 like that. You are done. Then also it's y is element of what you call real numbers like that. That's what you must always remember. So this one is restricted, but the other one is not. So now let's look at f of negative 1x equal to log 5x. Okay, let's check domain here. What do we see at the domain here? In terms of domain here, we can see that our x is no longer free there. It's restricted here because this one will never touch the what called the y-axis. Okay, so our x is restricted. So our x is greater than, okay, greater than 0. Okay, x greater than, it will never. The reason why we're not putting 0 here because this line doesn't approach x is equal to 0. So don't put the equal sign there. Now, what about the range? Range, in terms of the range, in terms of y, you can see that it's going down there until negative infinity and it goes up here until positive infinity in terms of y. So in this case here, y is just element of what you call of real number. So it can be any value, negative infinity to positive what you call infinity. That's what it means there. Okay, that's what it means in terms of our what you call our range in that case. Now, so let's look into the second scenario here where we are saying the what you call, where we are given, what is it? We are given f of x y equal to, what is it? 1/5, okay, to the power of x. Oh, sorry, y is equals to 1 over 5 to the power of x. So this is question 2. Okay, so our domain, our inverse there, we know that the what called the it's log. Okay, base is the same, 1 over 5. Okay, then what do we have? Our 2 there. So put a as a base. That's what we have there. Okay, now in terms of sketching, we know now what's actually going down there. Now here, what we have what is it? We do have straight line there. Okay, don't forget to label. Don't forget to label, please. That's how you show your Cartesian plane. Now here, what do we need to do now? We know that it's passing it 1. So here in stress, less stress here. Okay, less stress here. All right, now like that. Okay, then another one for it's passing it 1 again. Okay, what must it look like? Must. Okay, so here it's just a matter of mastering what you have learned here, and just see what's actually, these are just arrows that I'm just putting, but it's unnecessary though. Now, so that's what that's what we have there. This is what we have here. So we have a graph here. We have a graph here of what we call of y equal to 1 over 5. Okay, to the power of x. Okay, it's a fraction here. When it's a fraction, it's actually a reflection in the y-axis. Now here is f of -1, which is the inverse, equal to log, okay, 1 over 5 x. That's what we have here. But now let's check with the domain in this case here. Okay, so let's check with the domain. So y equal to 1 over 5 x. Let's check domain. Domain in this case here, for in this case domain, you can see that it occupies all the values of x, from negative infinity to positive infinity. So x is element of real numbers. Okay, then what about the range? The range here in terms of y, you can see that it's actually above. This graph will never approach x-axis, so y is greater than not equal to, remember, greater than 0. Okay, but also y is element of what called of real numbers. Okay, now let's go on to the second one, where we are saying, what is it? F of -1x is equals to log 1 over 5, okay, x. Now what will be our domain there? Domain is x values. So as you can see that in terms of x values that are restricted here is actually restricted, so it's going to be x greater than 0. Okay, x greater than 0. It will never touch the x-axis, but y-axis, but it just approaches y equal to 0, x equals to 0 line, which is y-axis. So it's just x equals to 0, like that. Then let's move on to the range. Range, what is our range there? Our range now is the y-axis. Okay, the y values, sorry. So let's check here. You can see that this one goes up until positive infinity in terms of y, then also goes down there up until negative infinity in terms of what? In terms of y as well. So y is not restricted. So y is element of real numbers. Element of real numbers. You're done like that. So it can be any value, which can be from negative infinity to positive, what you call infinity, like that. Okay, that's what I'm just talking about here. So this is what you need to understand in terms of what you call, in terms of your, what is it, your inverse functions. Okay, that's what you need to understand there. Okay, guys, this is the end. This is the end of our lesson. Okay, and don't forget to subscribe our YouTube channel, like our Facebook for updates, and also what you call Twitter, Instagram as well. Okay, and don't forget to share with your friends. Okay. Okay, so until next time, guys, thank you so much. Cheers.